Uh, Good morning, everyone, and thank you for joining us with the A&M University webinar through the technical issues. Hopefully, no more, no more this morning. My name is John Hines, the District Sales Manager in the Mid-Atlantic region, and today I'll be troubleshooting common challenges with cutting wheels, grinding wheels, and flap discs. The information in this webinar has been compiled from real experiences of district sales managers like myself. What we have seen and encountered in the field, working alongside distributors, speaking with operators, safety directors, and owners. The problems identified and causes defined are not exclusive to novice operators, but for all levels of experience. So consider the forthcoming information as an additional Weiler resource to help your company increase awareness of the most common problems that occur when utilizing cutting wheel, grinding wheel, and flap disc. Also, I will be sharing pro tips and best practices to increase productivity and cost savings. Next slide. All right, so just like at A&M, at Weiler, we think about the business, we focus on the customer, and we help get it done safely. Weiler products are designed and manufactured to the strictest standards to ensure the highest level of quality and safety. Always be aware and follow proper safety practices. Think about safety before you start your job and after you complete your work. Take the time to check your PPE for damage. Always inspect your tool and abrasive wheel disc or for any signs of damage prior to use. And always keep in mind, A&M was able to supply a catalog of all the PPE and tools and abrasives that you need. Correct, Mark?
That's correct.
Absolutely. So just talk to your local rep if you need a replacement or need anything new. Always important. All right, next slide. Okay, best practice recommendation for cutting wheels. Utilizing a rocking motion through the cut versus a hard pushing force is a valuable best practice to implement when using cutting wheels. This will greatly improve productivity, giving you a better balance of aggression and life of your wheel. So when I first used a cutting wheel on a handheld grinder, I was not aware of this technique. I started by pushing forward into the metal, just like I would with a circular saw cutting through wood. And I had a heck of a time controlling that grinder, and I wore that wheel out so fast, I barely made any cuts. Thankfully, after the suggestion was made to me, hey, relax your arms, don't tense up, and use your whole body to create a rocking motion moving through the cut. You're not working with just your arms. My experience was far more positive. These simple changes improved my control of the tool, allowed me to make more cuts, and see how efficient the wheel could be. Next slide. So let's talk about some problems that occur involving cutting wheels. Excessive pressure or leaning on the grinder will generate tremendous friction and heat at the leading edge of the cutting wheel. This increased heat and friction will cause the wheel to break down faster. Some users feel leaning on the grinder will increase the cut rate or performance. However, that is not the case. As you can see in the picture here, we have two identical wheels. These are both Tiger wheels. They were used by the same operator on the same tool on the same material. The smaller wheel was cut utilizing forward pressure and excessive leaning and excessive pressure. Whereas the larger wheel, same amount of cuts, but it was utilizing a rocking motion throughout the cut. So you can see a significant difference in the amount of wheel that's left there. Bond hardness greatly increases the performance and life of a cutting wheel as well. If the wheel is wearing too fast to effectively perform the required task, consider switching to a wheel with a harder bond. A wheel with a harder bond will help allow better retention of the cutting grains needed for removing material efficiently and improving productivity. Cutting wheels should always be stored in clean and dry locations. Moisture or excessive temperature changes can negatively impact the performance and efficiency of your cutting wheels. All Weiler wheels have a best by date stamped on the metal rings. Using a cutting wheel that is past its best by date can deliver diminished performance and life. So it's best to check the date and replace when appropriate. As you can see in the picture on the left-hand side, we have the best by date shown right there for you as well to quickly identify. And always, oh, sorry, back to one slide. Always utilize proper body position. Make sure both feet are planted firmly beneath you in a wide stance to help maintain your balance. Avoid tensing up your body. Stay loose and relaxed. Fluidity in your movement while cutting will help improve your cut and help you stay at the recommended 90 degrees to the workpiece. Okay, next slide. All right. Varying your orientation away from 90 degrees can create excessive side load stress on the metal flange. This stress can cause the wheel to break free and lead to injury. An important product note to be aware of, all wireless cutting wheels do have metal flanges in the arbor hole. If a workpiece is not properly secured, it can create excessive vibration. This stress can cause fractures throughout the wheel, causing the flange to break free. If your cutting wheel becomes pinched or bound between two pieces of metal, the grinder will continue spinning and it will rip the flange free from the rest of the wheel. I have personally seen this happening while testing other cutting wheels at a fab shop in Maryland. Fortunately, the guard was positioned properly between the wheel and the operator, so it broke free. When it broke free of the flange, the wheel did not strike the operator, and fortunately, no one was injured. When using a 7/8 open arbor cutting wheel, make sure the front and back flanges properly fit your grinder to correctly mount your wheel. The back flange should rest on the grinder spindle and not move excessively. The top flange should securely hold your cutting wheel in place and not allow the wheel to spin freely. There should not be any free movement of the wheel once it is securely clamped in place. A pro tip, after mounting the wheel, gently jog the tool by first holding the grinder away from your body and while not touching the workpiece. And turn the power on to ensure that the wheel is properly secured. If you notice the wheel is spinning out of balance, check the wheel and check the tool spindle and make the appropriate changes. Next slide. All right, damage edge. If you're applying sufficient pressure, if you're not applying sufficient pressure, the wheel will not bite into the material, which will create excessive extreme vibration or chatter. The vibrations can lead to frayed edges, as you can see in the picture to the right here. As mentioned previously, these cutting wheels are designed to be used at an orientation of 90 degrees to the workpiece. It is important to remember they are not reinforced for stresses on the side of the wheel. If you are using a cutting wheel for grinding or deburring, you risk injury due to breakage by placing excessive side load stress and weakening the structure of the wheel. If you do need to cut and grind, I recommend looking at one of Weiler's 1/8 open arbor or metal hubbed combo wheels, which are designed for deburring and light grinding as well as cutting. If a cutting wheel binds or stops during a cut, remove it before starting and re-entering a cut. Never try to restart a cutting wheel while it's inside the cut line or in contact with the workpiece. This is extremely dangerous. Next slide. Okay, well, now the questions up here. So first person to answer, to give the first two proper answers to this question. What are two causes of short product life of cutting wheels? You can answer in the chat, and at the end we will announce who the winner is. And Mark, if you will just track that and let me know at the end.
Yep. I'm watching the chat line, so the first two correct answers will win the prize.
Excellent. Okay, next slide. Oh, there you go. So we're going to move on to grinding wheels. And best practice recommendation here: long, smooth strokes versus short, choppy strokes. As you can see in the picture on the left, this is utilizing a long, smooth motion, whereas on the right here, it's really short and choppy strokes. You can see that the scratch pattern really is not very uniform, and this is going to create a lot of rework for the operator down the road. So by creating a uniform scratch pattern from the start, again, you can reduce the steps needed to reach your final finish. This will greatly improve your productivity and reduce costly wasted time and money. Next slide. So let's talk about problems that occur involving grinding wheels. A bent grinder spindle or damaged bearings in your tool can cause the wheel to spin out of balance, leading to uneven wear and possibly fractures in the wheel. A grinding wheel that has damage at the arbor will not mount properly on a grinder's flange and spindle. This damage can cause the wheel to spin out of balance. As you can see here in the pictures, the significant fractures in this wheel, and you can see to the left, you can see significant wear to the left of that wheel. So that's how you're able to see it's very quickly it's running out of balance. Also, be sure the back flanges fit properly on the grinder spindle. Loose fitting back flanges will not allow you to properly tighten the wheel to the grinder for optimal safe use. Wheels with a 7/8 open arbor require both front and back flanges to be securely mounted on a grinder. Wheels with a 5/8 11 metal arbor do not require these flanges to be on the grinder. At Weiler, we make grinding wheels with both a 5/8 11 metal quick change arbor as well as a 7/8 open arbor. The metal quick change arbors allow for faster changeover times and can eliminate possible cross-threading experience with non-metal threaded arbor products. Next slide. Uneven edge wear. So if you're pushing hard or using too much pressure, it is detrimental to the performance of both the tool and the grinding wheel. It will not make an abrasive work harder or faster. Rather, it will generate heat on the workpiece and will also dull the abrasive grains instead of exposing new sharp edges. If you feel the grinder getting too hot or you hear the motor slowing down, you are leaning on the tool more than you should. Now, grinding angle. A lower, flatter grinding angle will increase your wheel life, but at the expense of effective tool removal. If you are grinding on harder metals, the shallow angle will not be efficient to bite into the material. It will skate over the surface and your removal rate will significantly reduce, greatly decreasing your productivity. If you need an aggressive grinding wheel for use at lower angles, you should consider the Type 28 wheel from Weiler, or what's also known as a saucer disc or saucer grinding wheel. A steeper grinding angle, closer to 45 degrees, will allow for a more aggressive removal rate. However, keep in mind, it will increase the chances of gouging material by digging in too deep as you are grinding as well. Weiler grinding wheels are designed with a fiberglass layer cut back from the edge. This provides instant aggression on a new wheel out of the box. So when you begin using a grinding wheel, start with several pull strokes. By first reaching out safely with the grinder, then applying the proper amount of pressure, pull towards your body. This will help prepare the edge and keep you from gouging material and protecting your workpiece. Next slide. Inappropriate wheel choice. This is something I see often in the field. End users trying to utilize what is available, what they have, not what is best suited for the application. In fact, earlier this year, pre-COVID, I was actually out in Norfolk at a fab shop, and I was talking to some of the operators, and they were starting a job that was requiring a lot of aluminum grinding. And while I happened to be talking to the owner's son, and I noticed a considerably glazed, but not significantly worn grinding wheel. I explained that the glaze is aluminum coating the wheel and dulling the grain, thus decreasing the removal rate of the wheel. My recommendation was, rather than pushing harder on the grinder, try or tie your aluminum grinding wheel. The wheel is designed to be non-loading, allowing the wheel to continue biting into the material and expose sharp edges without having to exert pressure to make the wheel work. As you can see here on the right, the smaller wheel, this is a perfect example of a wheel being used on aluminum that is glazing and loading. Now, grinding wheels have either aluminum oxide, zirconium, or ceramic grains embedded in a resin bonding material. And as a grinding wheel is used, the grains fracture, to expose new sharp edges to continue material removal. Now, if there is inadequate pressure or you're using an underpowered tool, the grain will dull instead of fracturing, resulting in the wheels becoming glazed or loaded. This glazing or loading effect will also reduce the removal rate of the tool, greatly decreasing your productivity. Does your grinder have adequate power output for the grinding wheel being used? Tiger Zirc and Tiger Ceramic are two products with harder grains and bonds that require more power to help fracture the edges and break down the bond properly. So you should always consider your power source. If you're running a corded grinder off an extension cord, make sure you have the proper extension cord to ensure that you're getting enough power to your grinder. Next slide. Okay, best practice recommendations for flap discs. Again, proper grinding angle. It is important to have the best practice to implement when using flap discs. Will greatly improve your productivity, giving you a better balance of aggression in life. Weiler offers numerous styles of flap discs, as you will soon see. By having more options available, we can help provide the right solutions to improve your efficiency, reduce your costs, and improve your productivity as well. The picture to the right is utilizing a Type 27 flap disc at too steep of an angle. However, this angle is correct if you're using a Type 29 flap disc. If you're not sure what those two types are, I will explain in the next slide here. Next slide. No, thank you. All right, so as you see here from this slide, style considerations of flap discs. Weiler has a vast assortment of flap discs available, and when you take into consideration grain and grit options, wheel diameters, backing materials, arbors and styles or types, selecting the right flap disc can seem a daunting and difficult and confusing task. However, choosing the correct disc can greatly improve productivity and reduce waste. Right now, though, I'm going to focus on the four main types that Weiler offers, and these, of course, are available through A&M as well. So the first you'll see is the conical Type 29. It's the angled flap disc provides the most surface contact at a higher grinding angle and higher pressure. This is a flap disc I see most often in the field, and I'm sure many on this call can immediately recognize this style. Next to that, we have the flat Type 27. This will offer smoother grinding at lower angles and lighter pressure. This is more designed for blending and finishing on flat surfaces. The high density Type 27, this is designed for very aggressive stock removal on irregular and uneven surfaces. It conforms easier than a standard Type 27 flap disc because it's not as compacted down, so it has more give to it. So it's going to provide more comfort. And this last one, the angled Type 27 hybrid. Out of all of these, this is truly my favorite. This is has curved flaps for grinding fillet welds, T-joints, and other hard-to-reach areas. The flaps wrap around the edge of the disc to help optimize flap-to-metal contact. In fact, earlier this year, I had great success selling this wheel to a customer wanting to clean sharp edges on a curved surface. The curved flaps provided better control and allowed a better following of the curve of the material. In fact, Mark, it was with one of your sales guys, if you don't mind me saying, Dave McCardle, that he and I ran into that. So I just wanted to, I don't know if he's on the call or not, but I want to call him out for that. Next slide. All right, so let's talk about the problems that occur with flap discs. If you reduce your grinding angle, too steep of an angle will cause premature wear on the outer edge of the flap disc. By using a shallow angle, you will have more grain in contact with the workpiece, increasing the efficiency of your disc and improving your productivity. Please consider the style you are utilizing for the application. Sometimes simply switching from a flat Type 27 to a Type 29 will allow for more surface contact to the workpiece. Always remember, a longer lasting flap disc will help eliminate costly waste in the end. So often price is at the forefront of purchasing decisions. Weiler flap discs increase efficiency, reduce operator fatigue, and reduce costly waste. Flap disc may have a higher upfront price point than a grinding wheel. However, in spite of this, when you consider cut rate, life, consistency, and reduced work damage, it's not hard to recognize a well-designed product that will increase your return on investment. Next slide. Always make sure the discs you're using are appropriate for the workpiece material. Again, this applies to flap discs as well as grinding and cutting wheels. If you're working on aluminum, make sure your wheel is designed for it. A wheel not designed for aluminum will load quickly and lose its ability to cut. Sometimes you need to consider a coarser grain that is more aggressive. Flap discs have a broader range of grits than a grinding wheel, ranging from as low as 36 grit to as high as 120 grit. The higher grits have a more closely packed grain structure, and they're more susceptible to loading and typically used for finishing applications. So I was visiting a customer, again, pre-COVID, kind of thing to say now, and they were trying to remove mill scale from metal tubes prior to welding. And he was complaining of the costly, time-consuming rework and expensive, wasted abrasives. What he was doing, he was first using a specialized 36 grit ceramic resin fiber disc to first remove the scale. Then he was following it up with a 60 grit ceramic flap disc to remove the scratches the 36 grit disc was putting in. The problem became apparent when I saw the glazed flaps on the discs he was using. The flaps of the ceramic disc were not properly wearing and exposing fresh cutting grains. So my solution to him was actually to take a step back and try a 40 grit Wolverine zirconium flap disc. The Wolverine disc was able to remove the mill scale effectively without glazing and provide an acceptable finish. I was able to take his product cost down from a combined $8 for 2 abrasives to just $3 for 1 disc. Tiger angled hybrid flap discs are also a great option to choose over traditional flap discs for tight, hard-to-reach areas. They are also better suited for some applications that previously required carbide burrs. So that's something to consider. All right, next slide. Okay, to review. Pro tips for productivity. Always utilize proper body position and avoid pushing into the workpiece. Always gently jog the tool after securing your product to check mounting and balance. Be aware of your cutting wheel binding or pinching. The ideal grinding angle is between 15 and 45 degrees for a Type 27 grinding wheel. You should please consider Weiler's 5/8 metal hub grinding wheels for faster product change. And also, Tiger angled hybrid flap discs are a great option for tight, hard to reach areas over traditional flap discs. Next slide. Additional resources that Weiler offers. The troubleshooting guide, which this presentation was built off of, again, helped identify problems, define causes, offer safe solutions when using cutting wheels, grinding wheels, and flap discs. Next slide. Also, we have smaller catalogs as well, to call our metal fabrication catalogs, specifically focused to metal fabrication with the following products: cutting wheels, grinding wheels, flap discs, resin fiber discs, and wire brushes as well. Next slide. All right, hand it over to you, Mark.
Okay, so thank you, John. I have some questions here. Maybe I need some help. So
Okay,
let me read the first question. With regard to harder bond, what is rule of thumb to understand what is an appropriate adjustment in the bond? Should you take into account diameter as well?
So as far as bond, I'm sorry. Say it again. I apologize.
That's okay. With regard to harder bond, what is the rule of thumb to understand what is an appropriate adjustment in the bond? Should you take into account diameter as well?
Not necessarily diameter, so to speak. when you're considering a harder bond, usually you want to look at also at the power of your tool. If you're using a lower amperage tool, it's not going to have enough power to break down a harder bond. So look at your tool as well. Also look at the material that you're cutting. If you're cutting a harder metal, you don't want to go with a harder bond. You want to kind of go towards a softer bond, or like an Inconel type product. That's material that you're cutting. The material that you're working with is going to be a consideration. Diameter is really not going to come into play as far as a bond. It's more so your tool.
Okay. Now there's a John on the line whose question, two things. He typed in moisture and excessive force, but I don't see a specific question. So John, if you can give a more specific question, or John Hines, if you want to just comment on those two elements any more than you did already.
Oh yeah, moisture, absolutely. You know, now the temperature's changing, humidity in the air and kind of dampness in the air can actually affect the effectiveness of the bond of a cutting wheel. You know, they always say keep it in a good dry location. Don't let the wheel get excessively wet, because it can start to break down the resin that forms a bonded product. And excessive pressure, if you've ever cut with a circular saw, cut wood with a circular saw, typically you push forward into the material with a cutting wheel. So the same thing there. You don't want to. If you would go back, Mark, to go all the way back to the first slide for cutting. Right there. Yeah, so if you look through here, so the first picture showing motion through the cut versus excessive forward pressure. If you just kind of stay in one place and push forward, like I see a lot of guys do, that's creating a lot of excessive pressure on the front edge of the cutting wheel. It creates a lot of heat and creates a lot of friction, and that reduces the life of the cutting wheel. If you're working with the grinding wheel, same thing. If you have a wheel that's not cutting, a lot of people's tendency is to bear down harder onto the grinding wheel. And you'll be able to feel that in the grinder. You'll feel the grinder actually heating up, and that's how you'll know you're putting too much pressure. So you want to kind of have a fluid motion. You don't want to stay in one spot, so to speak.
Okay, I don't see any other questions. If there's anything else anybody can put through, but basically I wanted to thank everybody, especially for your patience in the beginning when we had a little trouble with the audio. I appreciate that. And just a little thing, we have another session coming up in 2 weeks for those who might be interested, coming back from COVID the Loctite way with Josh Decker of Henkel Loctite. But with that, unless there are any other questions, I want to thank you, John, again for the valuable information, and thank everyone for joining. And we'll send out the presentation and a link to the recording for anybody that's interested. So you'll have that as well, and it'll be posted on our website. With that, thank you, everybody, and have a great day.
Thank you all for attending. Thank you, Mark, for having me on. I appreciate it.
All right.
All right.